Assalamu alaikum wa rahmatullahi wa barakatuh. Last time we studied about solving inequalities and understanding their graphical representation. Let's continue our session with the next topic, which in the same chapter, which is absolute value function and inequalities. Before going in depth, first of all, we need to understand what is meant by absolute value. Absolute value in mathematics, it is an operator. It is the same, you can say, functioning operator as we have addition, subtraction, multiplication. But the process of this operator is whatever negative value you will have in the absolute value, we represent it by, if you want to say absolute value of x, we represent it by two bars, and inside you will write the variable or the number you want to mention or you want to apply this operator to. Uh, the function of or the operation of this operator is whatever value you will get, you will make it positive. Either it is negative, it means it cannot be a negative value. Whatever answer will be, it will be always a positive value. For example, if you have a operator of negative 10, so the absolute value of negative 10 will be 10. And same thing, if you have absolute value of positive 10, the answer will be also positive 10. So whatever value you are getting, either with positive or negative, the answer will always be positive. So let's go and solve some questions. Let's say we have our first question, which is, let's say 6m and absolute value is equal to 42. You will get such questions in your calculus. You will be solving this type of question. This is the simplest question to understand the concept of absolute value. So in this case, what you have to do, 6m can be either positive 24 or it can be negative 42. Either it is negative 42 or positive 42, and you will take its absolute value, the answer will be positive 42. So if you want to find the values of m, there will always be two possible values. First one with positive sign, the second one will be with negative sign. So from here, by using inverse property, it will be 42 divided by 6, and 42 divided by 6 is 7. So m can be equal to 7, or it will be m will be equal to negative 42 divided by 6, and the value of m can be equal to negative 7. So there are two possible values for this absolute value functions. All the time, whenever you will have absolute value function, there will always be two possible values. Either it is inequality or equation. We'll go for inequalities also. Let's check another example, which is a bit complicated than the previous one. Here you have negative 10, then absolute v plus 2. Now here the students will do mistake. They will say, oh, this cannot be negative, so it means this question is wrong. No, our main idea or our main concern is with this absolute function, it cannot be negative. But in this case, we have something outside also. First, you will solve this side and you will bring it, whatever you have, just absolute function on the left side and remove everything on the other side. So it will be negative 70, as negative 10 was in multiplication. So at this side, it will be in division, and negative 70 and divided by negative 10 is, I think so, it is 7. If you have any other answer, you can do let me know. So it will be positive 7. So from here, we will get two possible values, which are v plus 2 will be equal to 7, or v plus 2 can be equal to negative 7. And from here, v will be equal to 5, or v will be equal to negative 9. So there are two possible values. Okay, here there is a question. If in case you are getting an equation after simplifying, let's say we have negative 8x plus 4 equal to, let's say, 16. So what you have to do, first of all, you have to move this 8, negative 8 to the side. It will be absolute x plus 4 will be equal to 16 over negative 8, which will be equal to x plus 4 is equal to negative 2. So in this case, this absolute value function is equal to a negative integer, negative value, so which cannot be a possible, so there is no solution. Why no solution? Because the operator absolute cannot give you a negative answer. All right, if you want to do more practice, as I mentioned before, Kuta Software is a platform from where you can download free of cost worksheets for each topic, each lesson. Just you need to write the topic name. For example, for this one, you will write absolute value equation, and it will give you a worksheet of 20 questions with answers. So let's move to our next topic, which is absolute value inequalities, not equation. These are inequalities. So how you will solve this type of questions? Again, the concept is same, but the only difference here is you are having inequalities. So you have to understand what does inequality means. If in this particular question it is mentioned m minus 2 is less than 8. So if you will remove absolute value, m minus 2 will be less than 8, or m minus 2 will be greater than negative 8. Whatever value you have, you will put it a negative sign, and you will change the sign of inequality. So it will be equal to m will be less than 8 plus 2, or m will be greater than negative 8 plus 2, which means the value of m is less than 10. Means starting from here where 10 is not included, all the values to left side, but till when? Till you are getting the other value, which is m is greater than negative 4, as negative 6. So it means all values from from positive 10 till all values till negative 6, where both 10 and negative 6 are not included. So it will have all these possible values on this line where both 10 and negative 6 are not included. So if you are having inequality, the only difference will be this one. Let's go to our next question with inequalities, which is a bit complicated than this one. So in this case, the same concept as we studied from the equation. What you have to do, you have to move all things to on the right side and keep only absolute function on the left side. So from here, first of all, we will move negative 3 on the other side, which will be is greater than or equal to 78 plus 3. 78 plus 3 is 81, and then we have absolute 1 plus 8n, and as you can see here, 9 is in multiplication. On the other side, it should be in division, so you will have absolute 1 plus 8n is either greater or equal to 81 divided by 9. It is 9. So from here you can have you can remove the absolute value operator. So when you will remove it, it will be 1 plus 8n either can be equal or greater than 9, or it can be less than or equal to negative 9. So it means the value of 1 plus 8n is between 9 and negative 9, where both 9 and negative 9 are included. So from here, if you want to find the value of n, it will be 8n, 9 minus 1, which will be 8. So n will be greater than or equal to 1. Or the second value will be 8n will be less than or equal to negative 9, negative 1. So n will be less than or equal to negative 10 over 8. So it will be from here the value of n can be less than or equal to negative 5 over 4. So in this case, it's starting from +1, where +1 is included because it's equal sign, and then it is finishing at 1 point something, so it will go all the way -1 and 1.25 here, let's say is here. So all the values between 1 and -1.5 are included. So I hope this chapter is clear for all of you. If you want to do more practice or you have any question, you can ask in the comment section. Let's go to our next chapter, which is functions and the graphs. So what is meant by a function? In the function is normally a thing which is being operated. For example, you will have an input function, you will have an input which will give you an output. This is the main concept. So the input, you call it domain. Domain means the things you are providing, and output you called its range. We'll talk about range and domain in detail in next slide. So for now, we are just going to understand the function. You can represent function as f of x. You can represent, you will see p of x. You can see anything like g of x. It means this is a function of x, this is a function of x, this is a function of x. You can either represent it as f of t. It means we have something in which the variable is t. If we have variable theta, it means it will be, so it depends which variable you are using. It will be that variable will be written inside, or simply you generally it is expressed when it is written y. Y means actually it is a function. We can say y is equal to f of x when you are using x as a dependent independent variable and y as a dependent variable. Now, what is meant by independent and dependent variable? The variable in on which the function is depending means the input is always independent, and as the value, the output, the value of y is depending on the value of this independent variable, so it is called independent. For sure, it also depends on the functions, but on in one function, the behavior of the function or the working will be same. What is function? Function is like something you are going to do, or the function is going to do. You can, in simple word, you can say whatever value you will plug it here, the value you will give it to this function, so it will process that function according to the operator or according to whatever the function is and give you the value of output or as the result accordingly. So for example, if you have f of x is equal to x plus 2, this function describes whatever value you are going to give as an input. The function will add a value 2 in that and give you an answer. Okay, so this is the main concept of understanding function. So in these type of questions, you actually do not need to go in depth for the purpose of calculus, because this thing is like you just need to have a basic idea. For example, type of functions, there are different type of function according to the behavior. For example, you have one-to-one function in which each value of x, maybe you remember something Venn diagram, let's say 1 2 3 4, these are the values of x, these are the value of y, 6 8, let's say 10. So each value of x has a different value in y. It is giving you a different value after being operated by a function. So this is called one-to-one function, and then you have on-to-one function. So there are different types. Now let's talk about the domain and range. What is meant by domain? What is meant by the range of the function? As I mentioned before, domain means the input values input and the range is output. In simple word, this is what it is. Now, how we can represent domain and range? There are three different methods or three different notations to represent domain and range. The first one is interval method, which you can see with this one. If the values are included, let's say from we are talking about the domain where the value of x are between 1 and 2, where both 1 and 2 are included. But in the case where one of the values or two values are not included, let's say one is not included, so instead of this bracket, you will use a square bracket. It is 2 from 2 and 2 is included, you will use this bracket. This is called interval notation. Then you have other notation, which is this one, and the last one is set notation, in which you will write x such that you are describing which variable you are going to talk, x such that x belongs to a set of numbers. Let's say I'm saying it is belonging to a real number, and x is greater than or equal to 1, sorry, less or less than equal to 2. This is called set notation. So you can find any notation into your questions while you are doing exams or you are solving questions for calculus. So the concept of interval is same for either you are talking about domain or you are talking about the range. From domain, according to the category of the function, you can predict the behavior of the range. What will be the range? The general idea is, if you have a function, for example, f of x is equal to x plus 1, let's say we are talking about a linear function. So you can see if you will plug a negative value into the function, let's say negative x, so you will have negative x plus 1. So you are going to get a negative value if the value of x is greater than 1. Otherwise, you are going to get a positive value if it is less than 1. But in this case, what will happen? The range will be always negative when you have negative values of x. So according to the domain, what you have, you can predict the behavior of the range. We'll talk about this in the section of AND behavior and how can we identify AND behavior quickly. Now we have some basic type of the function, which are linear functions, quadratic functions, polynomial and rational and exponential and logarithmic functions. So first of all, what is meant by linear function? In linear function, the degree of the polynomial is 1. For example, as we discussed before, let's say it is just x plus a number, let's say 10. So it is called linear function, in which you will have only a straight line. Either it can be a decreasing or increasing depending on the leading coefficient. In this case, there is only one coefficient, which is the coefficient of x. But if you are talking about quadratic or other polynomials, so you will have different type of function. In quadratic, you will have degree 2. In polynomial, you can have any degree higher than 1 or even 1. All of them are in the category of polynomials. Then you have rational function. It is same as the rational numbers, in which you will have two polynomials in two polynomials into division form, where p of x cannot be equal to 0. So if any such function in which you will have these type of things, it will be a rational function. For example, you have a function f of x is equal to 1 over x. Then you have exponential function, e to power of something, or logarithmic functions. You have two type of log. Let's say we have f of x is equal to ln of x, or you have function log of, let's say, 3 base x. Both are same. The difference between this, both are from the same category, logarithmic. This is logarithmic function with base 3. Whenever you have logarithmic function with base 2, you will not write its base. It will be just log of x. It means it is absolute. The base is 2 here. And while you are writing ln, which is natural log, it means it is of base 10 of x. So there are some properties of logarithmic functions which we have covered in the previous sessions. So you can go for that, and while solving such type of questions, these are the main ideas you need to understand. For the function, what we have to do, actually, we have to understand mostly about their behavior, and for the purpose of calculus, if you know the basics, then I don't think so you need to do any other thing, because you already have studied how to graph a function and how we can know about the domain and range of a function. So we will go to a next lesson, which is graphing functions and interpreting graphs. Graphing function is similar to graphing equation because it has the same concept. You have to draw a t-table as we did in the previous session. For example, we have a function f of x is equal to x squared plus 1. So what we have to do, we have to draw a t-table where we'll have the values of x. Let's say 0, -1, -2, 1, 2. Now, in such cases, it is easy to draw functions by having a specific value. You don't need to always use these values which are starting from 0 and going on the left side and the right side. We can actually predict which value you should uh, start with by looking at the symmetry and the y-intercept and x-intercept of the function. This is what we are going to talk about. I'm not going to do the graphing thing because we already have studied how we can graph a function. So these are the main interpreting of graphs, which will help you to understand how we can graph a function and what are the possible things we have to know. What the first thing we are having it here, it's x-intercept. X-intercept means a point. For example, if you are having a point at which the function, the graph will cross your x-axis. For example, you have this xy plane, and we are having a linear function which is starting like this. So this is a point where the value of y will be 0. So whatever value of x will be, it will be known as x-intercept. The second point we are having is y-intercept. So if you are graphing any function, you can understand, you can know about x-intercept, y-intercept. And what is meant by y-intercept? Y-intercept means a point at which the value of x is 0, means it will cross your y-axis from here. Then line of symmetry in terms of linear function, you will not have line of symmetry, but if you are talking about absolute value functions, or you are talking about quadratic functions, let's say this is a quadratic function. So this y-axis at this case is a line of symmetry. We have understood while we studied the graphing absolute value and quadratic value functions, how we can know about the symmetry of the line, or if you are having absolute value function like this. So there was a formula which we studied. Then these two things, positive functions or negative function, it depends. Either the function is increasing with the value of x, or it is decreasing with the value of x, or it is above x-axis or below x-axis in terms of quadratic or absolute value function. If it is above x-axis, then it will be a positive function, and if it is below x-axis, it will be a negative function. This concept is only either with absolute value functions or the functions which are having positive, you can say, sorry, even powers like 2, 4, 6, 8. So in that case, you will have either positive or negative. But in the case while you are having the maximum power or the order of the equation as not even, they are not even, they are odd. For example, 1, 3, 5, 7. So in that case, you will have function will having both positive and negative values. Then the term comes increasing function. It means when you know on the graph the values of x are increasing from left to right. So as by the increase of the value in x, if the value of y is also increasing, then it means the function is going up and right. It means the function is increasing. But on the opposite side, contradictory, if you are having the value of x is increasing, but the value of y is decreasing, means the graph is going down to the right side. So it means the function is having a decreasing value function. It is a decreasing value function. Then we have relative maximum or relative minimum. It will come once you will have higher order polynomials, like the value is 4 or 5. We can talk about that later. Right now, we are going to talk about the end behavior, what is meant by end behavior, and what are the values, and how can we identify that behavior. And as I mentioned before, by using the technique of end behavior, you can actually predict the value, or you can predict the range of the function depending on the end behavior. So let's talk about it. So there are two things actually you need to be caring about. One is its degree, and the second one is its leading coefficient. For example, you have f of x is equal to x to power of 4 plus 3x. Let's say it is 2x to power 4 plus 3x 3 minus 4x square minus 2. So this is a function you are having. So the leading coefficient means the coefficient of the highest power. In this case, as it is degree 4, so the coefficient of x power 4 is leading coefficient. So you have to know its sign, either it is positive or not. If it is not mentioned, it is pretty sure it is positive. And the second thing you have to know, it is its degree. So in this case, the degree is 4. So what will happen if it is even, the degree is even, it means both side of the equation will go upward. But if it is and it is leading coefficient is positive, it means both sides will go upward. So degree will decide either both sides are going on the same side or no. For example, if we have an even degree, for example, we have a function f of x is equal to negative 2x square plus 3. So in this case, the degree is even, so it will describe that either the function is going to be upward from both sides, or function is going to be downward from both sides of the y plane, or from both extreme values. So how you will know it is upward or downward? By looking at the coefficient. If the coefficient is positive, it means both will go upward. If the coefficient is negative, it means both sides will go downward. And on the other hand, if you are talking about the odd degree, which means the degree is either 1, either 3, either 7, or all the odd numbers. Let's say we have f of x equal to x to power of 3 plus 2x square plus 3x plus 1. As it is having an odd degree, so it shows like in odd degrees, both sides will be opposite. If right side is going upward, left should go downward. If left is going upward, right should go downward. How you will know what is the scenario? Depending on the coefficient sign. The leading coefficient is positive here, so if it is positive, what will happen? Both sides will be, right side will be on the upward direction, means it is going to the positive infinity, and left side will go to negative infinity, means left side downward. And if the coefficient is negative, let's say it was here negative 2, so this will be the case. Right side will go downward, means towards negative infinity, and left side will go, when x is approaching towards negative infinity, left side will go towards positive infinity. So let's talk about how we can predict the domain and range of the function by using this end behavior. So it is pretty clear for us, for all polynomials, the domain will always be all real numbers. If you are talking about polynomials, the domain will always be all real numbers. Means always domain you will have starting from negative infinity towards positive infinity. Then by checking up on the end behavior of the function, whatever function is given, you can find or predict its range. Let's say we have f of x is equal to negative 6 negative 6x square plus 4x plus 1. So in this case, as the degree is even, so it means both sides will go upward or downward. So, and the leading coefficient is negative, it means they are going downward only. So it means the minimum value you can get is by plugging the value of x 0. So y will be equal to 1. So the maximum value of y will be 1. So it will start by 1 till goes, sorry, it will start by, so it will, the range will start by negative infinity and the maximum value it will attain is positive 1. So similarly, if you are having any other function, you can use the method of and behavior to find out its behavior or its range according to domain. All right, so let's talk about the transformation of the function. It is very easy. For example, you are having x square. What you have to do, you have to compare your given function with parental function. Now, what is meant by parental function? Parental function means the function which has some inheritance in the past. For example, if you are having quadratic function, so this is the parental function of a quadratic function. If you are having a cubic function, so x to power 3, this general form is the parental function of all polynomials having a degree 3. And see, similarly, if you are having y is equal to x to power 6, so this is the parental function for all the functions which are having a degree 6. So it can be anything. For example, it has x to power 6 plus x to power 5 plus 3 x to power 4 plus so on, whatever it is. So the parental function as the degree or the highest power is 6. So the parental function is this one. So what you have to do, you have to draw a parental function. Let's say for quadratic equation, this is the graph of parental function. And now you are getting another new function, which is y is equal to x square plus 2. So simply what you have to do, you have to move your x or your graph 2 units to the upward, because whatever value of x you will plug in, it will give you a result more in by 2 numbers. So your graph will move, your same graph will move 2 units upward. So you have uh, 4 types of transformation. One is translation, which is mean shifting. It can shift upward, downward, left or right. Or you have a stretching. For example, if I multiply by 2, so it will be stretch. If I will have 1 over 2, so it will compress it. For example, it will become like this. The actual parental function will come closer towards the y-axis. And then it is reflection. Reflection means it will go same as it is downward. You have studied all these things which are in grade 8, but in calculus you should just have an idea. They are not going to be used much. Thank you very much for listening. If you have any particular question regarding these topics, you can write in the comments. And inshallah, for the next lesson, we will be studying about exponents and radical functions. Till that time, take care. Assalamu alaikum wa rahmatullahi wa barakatuh.